So let's discuss a question from theory of machine. You are given with the gear, reduction gear, transmitted by the single reduction gear 200 kilowatts. So basically there will be a pair of gears, okay, in contact, and so by this single reduction gear there is basically two gears. The pitch circle is given of the pinion, so we will focus on the pinion. This is the gear. That the pitch circle of the pinion is given, the speed is given, the pressure angle is given, and the radial force acting on each wheel is asked. So on this, on the pinion, if you look at the pinion, what happens is that at the interface, assuming that this rotates anti-clockwise, the gear and the pinion, which makes the pinion rotating clockwise. So at this point you have, because of the pressure angle, actually you have a pressure something like this, because it's the line of the force. Basically you have a teeth like this, and the teeth of the gear will be acting in this way. So the force will be along this pressure line, the total force. But when you resolve that force, this is the total force, but when you resolve that force, you have a tangential force and a radial force. So let's understand, radial force is something which is passing through the center of the pinion gear, and so the tangential force is something which provides the torque and which makes the gear rotate, any gear rotate. Okay, because of this Ft you have a moment or a torque about this, and this Fr is something which is a compressive force, and there is a thrust on the gear which is supported by the shaft and the bearing. So this Fr is something which is asked to us. Okay, and this pressure angle is 20. Okay, so pressure angle is this 20. So how do we write the pressure angle? The tan 20 is nothing but from this equation. So if you, this is total force. Okay, so let's write down a force diagram, and this is tangential force, and a vector addition of tangential with the radial should give you the total force. And this is tan pressure angle with that. So pressure angle is always the pressure line, how much the pressure line makes with the tangent line. Pressure line is where the total force is acting. So tan 20 is nothing but the radial force by the tangential force. Okay, so radial force I need to get. So for that I need to, so this is how tangential and radial force are related with the help of a pressure angle. Okay, so now I need to get tangential force to get the radial force. Now tangential force is something, as I told you, tangential force is something that produces the torque. Now torque I need to get, but torque we can get from the indirect information that this much power is transmitted and with this speed. So torque, let's first get the torque. So, or why do we need to get the torque? Now torque produced by Ft on the gear is Ft into radius, which is nothing but diameter by 2. Okay, so in order to get Ft we need to get the torque. Now how is torque related to the power? So power is torque into omega, angular velocity, which is nothing but torque into omega is 2 pi n by 60. Okay, so let's get the torque first. So torque is nothing but power into 60 by 2 pi n. So power is given as 200 kilowatts. So 200 into 10 power 3 kilowatts into 60 by 2 pi, and this is 750 rpm. It rotates with 750. So this, if you calculate, you get closer to 2546.47 Newton meter. Remember, we are doing in Newton meter. Okay. Now once we get the torque, so I go back to this equation and get the Ft. So Ft is nothing but torque by d by 2. Now so it's 200 by 1, so it's 200 by 2, which is 100 mm, and 100 mm is nothing but 0.1 mm. So 2546.47 by 0.1. Okay, 0.1 is the in meters, so that we get about 2546 4.7. okay, this is Newton, sorry, because diameter we have taken meters, so 2. Okay, let me just this is the thing which we get. Let's come back here. So FT is 2546.47 by diameter is given as, let's look at the diameter. Diameter is basically 200 mm, so that is nothing but 200 by, so 100 mm is the radius. We need to put diameter by 2, so it is 100 mm. 100 mm is nothing but 0.1, so that goes 10, so 2. Okay, so here what we get is 2.47.1, so 0.1 if you divide, so 2.4647. so this is the thing, newtons. Okay, now we again use the radial thing. Radial is tan 20 of this, so 254,647 tan 20, so we get 9268 from this. Okay, wait a while, I mean there's something which we have done wrong. 2.46 by 0.7, so it is 4.7. okay, so this is 4.7, remember. Okay, this is what you get, 4.7 and tan 20, so 9268, roughly 9268 Newton is the answer. So 9268 should be the answer, roughly. Okay, so that is the answer. Thank you. So this is a simple problem. You have to just relate what you need to find out. Get the torque first, get the tangential force which drives the torque, and get the radial force. So 9268 is the answer. Thank you.